Good morning students, I am Aher from RBNB college from physics department. Today we study the chapter Gravitation. In this chapter we study the Kepler's laws. Now see the Kepler's laws of motion. Now in this case we consider three laws. The first law is law of orbit, second law is law of areas, and third law is law of period. Now see the first law of Kepler's first law of orbit, and this is the Kepler's law of planetary motion. See, law of orbit, it is all planets move in elliptical orbit around the sun with a sun is at one foci of the ellipse. Now here we consider, suppose there are the planet moves in a elliptical orbit. This is the ellipse. Now in this case the planet moves in elliptical orbit. See, in case of ellipse this is the center. Now in this case this is not circular motion, this is the elliptical motion. There are in ellipse there are two foci. Now we consider here sun is at one foci. Now see, this is the distance A, it is called as semi-major axis. This is the A distance, this is also A distance, it is called as semi-major axis. Now the total distance, it is 2A, and the distance is, or it is called as major axis. Now see, this is the minor axis, that is the distance OM and ON are the minor axis, and total distance is 2B, it is the minor distance or minor axis. Now see the distance B, it is the semi-minor axis. This distance B, it is also the semi-minor axis. See, this is planet, all planets move in an elliptical orbit where sun is at one foci. In this case, the foci, there are two foci S and S'. S and S' are the two foci of ellipse. P, the point P, it is closest to sun, hence the point P is close to sun, it is called as perigee or perihelion. Now the point A is at fastest point, and it is called as apogee or apohelion. The distance PA, see this distance PA, it is called as, it is equal to 2A, and it is called as major axis. The distance OP, it is equal to A, it is called as semi-major axis. The distance OA, it is also A, it is also called as semi-major axis. The distance 2B, that is it is 2B, that is MN, it is 2B, it is called as minor axis. The distance B, it is called as semi-major or semi-minor axis. See, here we consider the first law of planetary motion. All planets moves in elliptical orbit around the sun. Now in this case sun is at one foci. All planets move in a elliptical orbit where sun is at one foci. This is the first law of orbit, that is all planets moves in a elliptical orbit around the sun with sun is at one foci. This is our first Kepler's law. Now we see the second Kepler's law. The second Kepler's law is that is aerial velocity is constant. That is, we can say the aerial velocity is constant. That is the sun and planet sweeps equal areas in equal time. This is the second law of areas, and that is the aerial velocity is constant. In this case aerial velocity, that is dA, by dt is equal to constant. Here dA, it is the change in area, dt is the change in time. This is dA by dt. This is called as aerial velocity and it is constant. Now see here, see the sun is situated at here, that is one foci of the ellipse. When the sun is or the planet is near to the sun, the motion of the planet, they move very fastest, while when the planets at the apogee or it is at the perigee, then it moves the slower. Now the rate of the aerial velocity dA by dt, it is constant. Suppose we can say that the area is here A and time is t1, area here is A2, time is t2. Therefore we can write here A1 divided by A2, the A1 divided by T1 is equal to A2 divided by T2 is equal to A3 divided by T3, which is equal to constant. Which is equal to constant. That is aerial velocity, the time. This is equal areas in equal time. Therefore, we can say that aerial velocity is constant. Now, here we see the delta A is equal to this is the area and we can say it is 1/2. Now see here area of the triangle, is 1/2, that is r. It is suppose this is r and this is suppose height and this distance covered is, now you know the distance is or velocity is equal to distance upon time. Distance upon time. V is equal to distance is suppose s and this is the delta V is the velocity, time is t. Therefore s is equal to delta V into t. Here we can write the distance covered in time t, it is delta V into t, delta V into t. See, here we consider the aerial velocity, area of triangle, it is 1/2 base into height. This is suppose base and this is the height. Then we can say area of the triangle is equal to 1/2 r into this is the distance, this distance pp dash, and which is nothing but distance covered by planet, which is equal to delta V into t. Now we rearrange the equation, we get that is, suppose we have the linear momentum. Let P is linear momentum. P is linear momentum. We know linear momentum is product of mass into velocity. Then here we substitute for V is equal to P upon m. Substitute the value of V in this equation, we get V into dV, or we can say substitute the value of V in this equation, we get delta A is equal to 1/2 r into value of V, it is P upon m into T. Now see this value, that is P, or substitute the value of this delta T, this is into delta T, V into delta T, this is T into V, then V into delta T, it is C, delta A divided by delta T is equal to 1/2 r cross P divided by m. Now in this case we know L is angular momentum. Then angular momentum is given by, the angular momentum L is equal to r cross P. Then here substitute the value of r cross P, it is 1/2 L divided by m. Now, in case of this elliptical motion, angular momentum is constant. It is constant. For central force, it is constant and angular momentum is constant here. L is constant, m is constant. Therefore, this aerial velocity is constant. This is the second law of the Kepler's second law of the area, that is aerial velocity of the planetary motion is constant. Sun and planet sweeps equal area in equal time, that is dA by dt, it is equal to constant. Now we see the third law of period. See, in this law, see, suppose this is the semi-major axis, this is the semi-major axis, and t, suppose t is the period. T is the period. What is the period? Period is time taken to complete one revolution. It is called as period, and t, that is, this is period. This period, square of period is directly proportional to semi-major axis, cube of semi-major axis. That is, we can state the laws of period. It is square of period, period of revolution, is directly proportional to cube of radius of semi-major axis, that is t square is directly proportional to r cube, that is t square divided by r cube, it is constant. These are the three laws of the Kepler's three laws of the planetary motion. See, the first law, that is law of orbit, that is its statement, all planets move in an elliptical orbit around the sun where sun is at one foci. The second law, that is aerial velocity is constant. The sun and planet sweep equal area in equal time, that is dA by dt is constant. And the third law, that is the square of period of revolution is directly proportional to cube of radius of semi-major axis, that is t square is directly proportional to r cube. Thank you.